Take a second to sit down and relax. Don't try to think about anything. Just let your brain sit quietly for a second, taking in the sights and sounds around you, without any thoughts about the past, present, or future. Take a second to just exist. Were you able to do it? Now, think back. As you sat quietly for a moment, did you have the experience of a little voice inside your head, incessantly narrating what was going on, what you saw, how you felt? If you're like almost everyone, the answer is yes. But what is the origin of that voice? It's almost as if there's another, smaller person inside your head, narrating everything you perceive to you as you experience it, sometimes even against your will, as you likely just experienced. This idea has been given various names by philosophers and psychologists over the years: the homunculus, or little man in your head, the Cartesian theater of experiences that play out like a movie in your mind, and many other things. But there's a fundamental problem to this way that many have of explaining what it subjectively feels like to be conscious. It's completely ridiculous, a fallacy through and through. If there's a little man in your head watching a screen with all the information coming through your senses, wouldn't there have to be a little man in his head, and a little man in his head, and so on? It's turtles all the way down. We live our entire lives within this stream of conscious experience, but so infrequently do we stop and consider what this idea of consciousness actually is. Is there something central guiding our thoughts, or are our thoughts the byproduct of 100 different streams of consciousness, coming from thousands of different neural circuits, competing incessantly to rise to the top of our attention? And if we're simply selecting a stream of consciousness, where does it come from, and what makes it a stream of consciousness as opposed to any normal neural firing pattern? Is there a fundamental difference between the information that goes into our cortex and what ultimately emerges? Now, there are no easy answers to these questions. However, you may be surprised to learn that there is evidence, real, peer-reviewed, empirical data, that hints at what this concept of a conscious mind really is, in scientific, concrete terms. And today, on the Last Turtle podcast, we're going to take a look at what neuroscience has to say about the nature of consciousness, and hopefully get just a bit closer to figuring out where that internal narrative is really coming from. And just maybe, we'll be able to throw out the little men and the turtles, all of them, that is, along the way. One important question, which is being explored more and more in neuroscience, is how the perception of sensory experience in humans differs between that of animals, if it does at all. Of course, we know that we process what we see, hear, and feel differently based on our current state of wakefulness and arousal. For instance, in one study, firing patterns in the cortex were measured in mice across a range of physiological arousal states, which was measured by the degree of pupil dilation, and that itself is modulated by levels of cholinergic and noradrenergic receptor activation. And I should mention here that the researchers were able to induce several arousal states in the mice based on whether they were moving or staying still. The researchers found that synchronous and spontaneous firing, which is a normal part of your everyday waking state, were suppressed in the more aroused subjects, indicating that they were allowing the circuits that detect and recognize novel stimuli to take precedence. In other words, how much background noise makes it to the forefront of your conscious brain depends heavily on what you're doing and how awake you are at a given moment. However, the question in this case comes in when you ask yourself which stimuli in the environment around you will elicit physiological arousal and break through, so to speak, into your conscious awareness. Now, if I'm sitting in my room and a bird lands on the windowsill, my cat loses his mind. And you can actually see it sometimes. His pupils will triple or quadruple in size. Extending that last study, we can hypothesize that all the synchronous firing patterns in his visual cortex are going out the window when he sees that bird, and all of his conscious attention is focused on the stimulus. I, on the other hand, am not going to give that stimulus a second thought. I'm not even going to notice it, all things being equal. We can see from this example that at a neurological level, your pet's prey drive is attuning them to a very different conscious experience than the one you're experiencing, despite the fact that you may be receiving similar sensory input, although of course, as we know, it will not be exactly the same. So what does this tell us about the nature of consciousness? We tend to assume that what we call consciousness arises directly from how we perceive the stimuli around us. We feel that we are conscious because of that metaphorical man in our head who can receive information about what we see, hear, and touch, who can predict future outcomes, think about what's going on, and otherwise interact with the world. But consider this. If something as routine as whether we're out for a run or sitting at a computer, or whether we've had our morning coffee yet, can vastly change how we perceive our surroundings. If that's the case, then could it be that our intuitive feeling about what consciousness is wrong? To put that in more biological terms, could we say that we are more conscious when caffeine is blocking our adenosine receptors, or our cholinergic activity is higher because we're out for a jog than when we've just woken up? I can hear the objections already. Wait, you're saying, everything you've described, seeing, hearing, detecting objects around us, making predictions, interacting with others, those are all things animals do too. That's not what makes up human consciousness. That's not what makes us unique. There must be something more going on here. So perhaps what I've described up until now is not consciousness. Or perhaps it's a sort of prerequisite for consciousness. That is, sensing things and making predictions and using language are required for consciousness, but we couldn't say that they are consciousness. Then what does make us conscious, after all?
What we are, what each of us is, what you are, what I am, is approximately 100 trillion little cellular robots. That's what we're made of. No other ingredients at all. We're just made of cells, about 100 trillion of them. Not a single one of those cells is conscious. Not a single one of those cells knows who you are or cares. Somehow, we have to explain how, when you put together teams, armies, battalions of hundreds of millions of little robotic, unconscious cells, not so different really from a bacterium, each one of them, the result is this.
Now, what this is, in this talk by philosopher and cognitive scientist Daniel Dennett, is a visual representation he's showing on the screen of a so-called stream of consciousness, an unfiltered chain of words, pictures, and ideas that flow together, arriving one after another to the forefront of our thoughts.
I mean, just look at it. The content, there's color, there's ideas, there's memories, there's history, and somehow all that content of consciousness is accomplished by the busy activity of those hordes of neurons. How is that possible?
How is that possible? How is it that billions of those tiny biological machines which we call neurons can collectively produce a subjective feeling of somehow being more than the sum of those parts? What is the process that leads to this subjective experience, and how can we discover what that process is?
The centerpiece of the science of consciousness in recent years has been the search for correlations between certain areas of the brain and certain states of consciousness. We saw some of this kind of work from Nancy Kanwisher and the wonderful work she presented just a few minutes ago. Now we understand much better, for example, the kinds of brain areas that go along with the conscious experience of seeing faces, or of feeling pain, or of feeling happy. But this is still a science of correlations. It's not a science of explanations. We know that these brain areas go along with certain kinds of conscious experience, but we don't know why they do.
That's David Chalmers in a TED Talk he gave in 2014. Chalmers is one of the leading figures in theories of consciousness. He touches on a few points here that will be very important. First, what are we measuring empirically when we study consciousness? That is, what brain regions are we looking at, and when are they most active? Believe me, we'll get there, Now, first I wanted to lay out some of the current hypotheses about how consciousness arises in the first place. As a quick aside here, I came across Chalmers' talk even before I found out that he's actually the guy who coined the term hard problem of consciousness. Part of this hard problem is the question not of what we observe consciousness to be, but rather why we have subjective experience, when simple processing of and acting on information without thinking seems like it would suffice to keep us alive and reproducing. Additionally, even if we could answer that, we would be no closer to understanding how consciousness arises from obviously unconscious cells. All of this to say, Chalmers happens to be regarded as a rather authoritative figure on the subject.
In the 19th century, Maxwell figured out that you can't explain electromagnetic phenomena in terms of the existing fundamentals, space, time, mass, Newton's laws. So he postulated fundamental laws of electromagnetism and postulated electric charge as a fundamental element that those laws govern. Well, I think that's the situation we're in with consciousness. If you can't explain consciousness in terms of the existing fundamentals, space, time, mass, charge, then as a matter of logic, you need to expand the list. The natural thing to do is to postulate consciousness itself as something fundamental, a fundamental building block of nature. This doesn't mean you suddenly can't do science with it. This opens up the way for you to do science with it. What we then need is to study the fundamental laws governing consciousness, the laws that connect consciousness to other fundamentals, space, time, mass, physical processes. The second crazy idea is that consciousness might be universal. Every system might have some degree of consciousness. This view is sometimes called panpsychism. Pan for all, psych for mind. Every system is conscious, not just humans, dogs, mice, flies, but even Rob Knight's microbes, elementary particles. Even a photon has some degree of consciousness. The idea is not that photons are intelligent or thinking. You know, it's not that a photon is racked with angst because it's thinking, I'm always buzzing around near the speed of light. I never get to slow down and smell the roses. No, not like that. But the thought is maybe photons might have some element of raw subjective feeling, some primitive precursor to consciousness.
Here, Chalmers has explained what he calls two radical ideas of consciousness. The first, as he phrases it, is that consciousness is a fundamental building block of nature. Like space, time, and mass in Newtonian physics, consciousness is an idea that cannot be broken down into simpler terms, an atom of existence, if you will. The second idea is the one that has come to be known as panpsychism, the idea that everything is, to some extent, conscious. This extends from humans to animals down to bacteria and even a photon. The difference, he suggests, is that the so-called degree of consciousness scales with the complexity of the entity's information processing centers. A human brain, which takes in, filters, and acts upon many different stimuli, both past and present, can support a vast amount of conscious thought. A relatively intelligent animal, having the ability to process far less information than a human, but an enormous amount compared to, say, a bacterium, is not as conscious, but is conscious nonetheless. Following this reason all the way down to a simple photon, which ultimately has the ability to process little or no information, and it has a minuscule, yet still appreciable amount of consciousness. So, what we've seen is that in our quest to come up with explanations for what this enigmatic thing we call consciousness is, we've managed to generate some pretty wild hypotheses, ranging anywhere from consciousness doesn't exist to everything is conscious. What are we to make of this? The most solid starting point, it seems, is to look at what neuroscience can tell us about consciousness right now, using empirical data collected via methods we currently have at our disposal. As David Chalmers alluded to in his talk, the best method we currently have for empirically determining what this thing is that we call consciousness is searching for correlations. These are referred to in scientific terms as neural correlates of consciousness, or NCCs. The idea here is that if we can identify brain regions that consistently increase their activity during particular conscious experiences, we can start to build a map linking biological structures to conscious thought. There are two key neural correlates of consciousness that have made it to the forefront of research on the topic in recent years. The first is perceptual bistability, most easily illustrated using the famous Necker cube. Now, this is really just an image of a cube with only the outlines of the edges showing. One can view the cube as facing upward or downward depending on how they choose to perceive it. A less obvious example is that of the spinning dancer. If you haven't seen it before, the animation shows a woman spinning in circles ad infinitum. The catch is that the image is purely a black shadow, so that you can't tell just by looking at it at a glance whether the dancer is currently facing forward or backward. Initially, most people report seeing the woman spinning either clockwise or counterclockwise. The animation, again, is ambiguous, so neither perception is correct per se. However, with some practice you can manage to flip the animation in your head, so that if you originally perceived a counterclockwise spin, you could now see it going clockwise, or vice versa. A third well-known example of this phenomenon is the famous Neisser and Becklen experiment from 1975, in which participants were shown two overlaid videos at the same time on the same screen. The effect is similar to looking at a partially reflective window. You can easily see either your own reflection or whatever is going on outside, but you cannot perceive both simultaneously. And of course, participants in the study experienced the same. They could easily direct their conscious awareness to either overlaid video, but ask them to describe what happened in the one they weren't watching, and they have no idea, despite the fact that the information from each video was consistently entering their retinas the whole time. Perceptual bistability, then, is this idea that you can perceive a stimulus in different ways, despite the fact that the actual information reaching your retinas is the exact same. This isn't much different from the example with the cat and the bird, where the same information reaching the eyes of both you and your cat will elicit vastly different levels of arousal and the corresponding neural activity. A question arising from these examples is there ever a situation where we can perceive information outside of conscious awareness? Now, it might seem intuitive to say, no, that's impossible. But take, for instance, the phenomenon of blind sight. Participants in the initial blind sight studies were truly blind. That is, they experienced no conscious perception of the visual world at all. However, when asked to maneuver an obstacle course or point to an object in front of them, they appeared to be able to do so. The question at hand, of course, is how they managed to do this. Are these participants somehow processing visual information through a different pathway, not involving the primary cortical vision centers, what we call area V1? One that is not in our conscious awareness, but is still able to direct actions? Recent evidence suggests that feed-forward mechanisms may be at play. Here's an explanation from Dr. George Mashore of the University of Michigan at the 2018 Science of Consciousness Conference.
Not only is there processing in the feed-forward direction from V1 to the prefrontal cortex, but there's also feedback processing. And this appears under a variety of different guises in the literature. It's been termed reentrant processing, recurrent processing, reverberant processing, reafferent processing, feedback processing. The idea is the same. Given a hierarchical brain organization, higher order areas receive input, but then they also feed back and influence more primary or lower order areas.
Now, this is a really interesting idea, and recent literature actually supports the idea that this top-down control from the cortex is necessary even for blind sight. In a paper by Mikko Hurme and colleagues at the University of Turku in Finland, the researchers describe previously healthy participants who have their primary visual areas temporarily inhibited by transcranial magnetic stimulation, TMS. Unlike typical blind sight subjects, they are unable to process objects or motion in front of them without use of their area V1. This suggests that in real blind subjects, the visual areas are being used in a different way, because only those subjects who have over time rewired their brains to send different stimuli to the visual areas can navigate their environment while blind. The researchers conclude saying that Neurologically healthy observers cannot process motion unconsciously without functioning of V1. In other words, some type of top-down modulation of visual information is still necessary for the conscious perception of objects. There is conflicting evidence in this realm, though. For instance, a 2005 experiment by Alan Pegna and colleagues at the University of Wales described a case in which a participant still responded to emotions and faces despite not being able to actually see them. Ultimately, then, we're still left with the question of what, if any, processing beyond conscious awareness contributes to conscious action. A related NCC in this area involves the phenomenon of perceptual bistability. A classic study by Frank Tong and his colleagues at Harvard University in 1998 involved a set of images. A house was visible to one eye, while a face was visible to the other. The researchers found that changes to conscious attention correlated strongly with changes in brain activity in certain regions. For instance, focusing on the house activated the parahippocampal place area, while focusing on the face elicited greater activity in the fusiform face area. There is one thing these studies seem to share in common. All of them suggest that consciousness is somehow linked to neural activity. It's clear that bursts of activity in certain regions of the brain, especially certain regions of the neocortex, are strongly correlated with subjective reports of certain types of conscious thought. Of course, we're really no closer to solving the hard problem of consciousness than we were before. Questions regarding why we have consciousness, or precisely how neural activity is converted into conscious awareness, remain unanswered. Perhaps one day we will be able to simulate entire circuits of neurons and carefully, empirically measure each step in the development of conscious thought in a non-biological organism. But that's another whole can of worms, which we won't get into today. However, I hope that, at the very least, you're able to leave with a few key understandings about consciousness. Firstly, that it is crucial that we continue to refine our techniques for collecting empirical data on human consciousness, so that we may be able to more definitively reject or support the ideas posed by some of the thinkers we heard from. Secondly, I hope that I've sufficiently convinced you to abandon the preconceptions we hold about the simplicity of conscious thought. It's time we did away with the little man and the turtles. And above all, I hope that you'll take away that consciousness is so much more than what we perceive. Or is it? Thank you all for listening, and if you're interested in this type of material, I'd highly encourage you to support the Human Consciousness Project. It's an ongoing project being run by the Nora Foundation, a nonprofit out of New York City, which is an international consortium of multidisciplinary scientists and physicians, and they're trying to better understand the hard problem of consciousness by looking at changes in human consciousness as people die. So they view the process of death as not being a single moment, but rather a very well-defined medical process. And so they're attempting to measure these neural correlates of consciousness in people that are going through death. So it's a really interesting project, and I'd highly encourage you guys to check it out. Thanks for listening, and see you next time on the Last Turtle Podcast.